we'll now learn about functions. So you might ask, and you should ask, why should I care about functions? Well, there are many reasons. The main principle of functions in a program is to identify and separate different functionalities of the program. So to isolate some part of the program that has to do with printing, let's say, and some other part of the program that has to do with getting the information that it has to print, and yet another part that has to do with computing the actual stuff that will be eventually printed. So why would you do that? Why would you separate all those different functionalities? Well, the main reason is to facilitate reuse. So you will realize that some part is done again and again, like fetching data, and you want to isolate that so you can reuse that little part more easily. Also increases readability. So if someone else tries to read the program, they'll know that that part is supposed to deal with fetching the data, and that other part is supposed to deal with more the calculations. And that helps readability, and it also helps development in the same step. And finally, isolating functions like this helps also maintain the code, because you can isolate the different components and you can test them separately. You can make sure that they work as they should separately. So you modularize the tests as well. Okay, so those are all the reasons for why you should use functions. Let's look at an example here. And the example comes from the Roman numeral homework. So here we have some example solution. So we have the digit of the tens here and the digit of the units. So I didn't go into the hundreds, but you can imagine that this program could have an extra few lines at the top that look very much similar to this block here that would deal with the hundreds. Okay, so the point here is that if you solve it this way, you essentially solve it by copy-paste. You solved the problem, let's say, for the units, and you see that the behavior will be something when the unit is 4, something when the unit is 9, and otherwise something else that it does. And then you realize, hey, wait a minute, I'm trying to solve for the tens now, and this will be very similar to the units, so I'll copy-paste my code here, and I'll do exactly the same thing, except I replaced IV by XL, right? And I replace IX by XC, and V by L, and I by X. Okay? And you replace units digit by tens digit as well. But essentially, otherwise, it's the same thing. And if you were to do the hundreds, as I said before, you would have another block that is copy-pasted right above it, and you would edit it in a similar fashion. So you can identify here that some functionality in the computation is repeated again and again for the units, the tens, and the hundreds. And you want to improve this. You want to define the functionality just once and then reuse it by changing the parameters a little bit. And that's what a function will do. Okay, so what we'll do is we'll package the unit of work, and that's called a closure, and we'll give it a name. And the name will help us call it again and again. So this will define a function, and the function definition appears only once, but then we'll do multiple function calls with possibly different contexts. So what does this mean? Well, in the previous example with the Roman numerals, we're doing something 3 times for the units, the tens, and the hundreds. And what does it do? Well, it processes a digit, 1 digit at a time. So the function definition is to process a digit, and the function calls here, well, there would be 3 of them, 1 for units, 1 for tens, and 1 for hundreds. So the context will slightly change, and what's the context that changes? Well, here I would switch from I to X to C, right? The Roman letters change from V to L to D, and from X to C to M. Okay, so from I to X to C, that's one context that changes. Another one would be from V to L to D, I think, and so on. So one observation about functions that's not relevant for the Roman numeral example, but will be relevant in mathematics and in some of your homework, is that functions can call themselves again, and this is called recursion. So within the function definition, you can also have a function call to the same function, but that's fine. Conceptually, it's not so hard to understand. It might be actually harder to implement, but it's at least conceptually, it's not so hard. Okay, so what do you do with those functions? Well, in general, you compute something, and then you have the option of returning a value or not. And if you return a value, that's called a function, really, a real function if you want. And the value that's returned can be any Python object. On the other hand, you have a procedure, and in Python, you can give it the name procedure. You cannot officially give it the name procedure, but you can informally call it a procedure. And the point is that it doesn't return really a value, so it will return none. That's really what happens behind the scene. But you don't have to make it explicit. You can just not return anything, and the Python interpreter will add return none on its own. Now, a function also has some parameters, and the parameters serve as input to the function. So in the definition, the parameters are formal parameters. You just name them. You just give a name. You don't give a value. And the actual parameters or arguments of the function call will be bound to the formal parameters by an assignment. And there are still different ways of specifying parameters at the time of definition and then at the time of call. And Python has two types of those: positional and keyword or named arguments. And you will see that positional arguments can be understood as a list, while the keyword arguments can be understood as a dictionary. So let's see an actual example of a refactoring of code that is done through functions. And this is, again, this example with the Roman numerals. So we have the units, we have the tens, and by lack of space, we also have the hundreds that are ignored. And here on the right, I have the same program, in the sense, the same functionality, but packaged differently. So what I'll do is I'll do a definition of a function, and this definition, the name of the function is Roman digit. So it will handle one Roman digit at a time, and it takes as argument a digit and some list of symbols, or some tuple of symbols actually. And I will assign low, mid, and high. I will bind low, mid, and high to the components of symbol. And then I'll do different things depending on what the digit is. So if the digit is 4, I return the low one plus the mid one. If the digit is 9, I return the low one plus the high one. And otherwise, I'll do some trick with modulo 5 to return the right thing. So that handles one Roman digit at a time in the abstract, regardless of whether it's a unit, a tens, or hundreds digits. But then I can do the actual call. So this is the function definition here, and below are the function calls of Roman digit, where I specify the actual values of the parameters. The parameters here are formal, digit, and symbols. That's the formal parameters. But then I pass some values, and I pass the tens digit, which I assumed is already defined before, right? On the left as well. I assumed this was already defined. And then I also pass the symbols, and the symbols will be a tuple, a triple in this case, of parameters, which will be the letters to use. So if you're looking at the tens digit, then you have X, L, and C. But if you're looking at the unit digit, then the low one is I, the medium one is V, and the top one is X. So you see that we've packaged all the functionalities that was there into one, all the functionality that was repeated twice here, or maybe even 3 times if you count the hundreds. We have abstracted this and packaged it here only once, and we have parameterized the things that changed between the different blocks on the left. So for instance, this. So this is now packaged into that guy here. Okay, so this is low plus mid, and it's packaged there. So why is there a gain? Well, the gain is that if our logic here is wrong, then we fix it in one place instead of fixing it in 3 places and copy-pasting the fixes if you want. Okay, so this was a basic explanation of functions in Python. We'll see now different aspects of those functions. For instance, how do you specify the parameters? How do you specify default parameters? Things like this. But this is already quite sufficient to get you started at building complicated programs. And really, once you understand functions on top of dictionaries that you learned this week and all the stuff you have learned so far, you really know basic Python, and you can already build very complicated programs.